Hi everyone. For those of you who have not yet completed the atom activity using the Gizmo's Element Builder simulation over here, I'm going to go through this assignment and activity with you. So open up your atom activity worksheet. It's a Google Doc and you should have got it off of your Canvas page for your class. So if you still need to go get that, go open your Google Doc, have it open in another tab so that you can follow along and complete the assignment as we are working our way through this together. All right, the first part of this assignment is prior knowledge. So you're not using the Gizmo for this one, you're using what you've already learned in the past. Number one, what are some of the different substances that make up pizza? What parts does a pizza have? Type in all the different parts or ingredients that you can think of in this box. What substances make up water? We've talked about the chemical symbol for water a little bit, H2O. You've probably heard that a lot of times. So what is it that makes up water? Finally, what substances make up an iron pot? All right, let's take a look. It's important to complete this assignment where you read every part so you can follow along with me here. Elements are pure substances that are made up of one kind of atom. Pizza is not an element because it's a mixture of many substances. Water is a pure substance, but it contains two kinds of atom, oxygen and hydrogen. Iron is an element because it's composed of only one kind of atom. So thinking about that explanation, how does that relate to what you put up here? Were you thinking along the same lines? All right, let's do a warm-up activity with the Gizmo over here. And again, follow along as we read through the instructions. Atoms are tiny particles of matter that are made up of three particles: protons, neutrons, and electrons. The Element Builder Gizmo shows an atom with a single proton. The proton is located in the center of the atom, called the nucleus. Anytime you see something in red on the worksheet, that's something that you need to do on the Gizmo simulation itself. So you can watch and follow along as I manipulate the Gizmo and follow these instructions, or you can open the Gizmo up yourself using the link up here and try it out yourself. So number one says use the arrow buttons to add protons, neutrons, and electrons to the atom. So let's do that. Here's the arrow buttons. I've added 4 protons. I can see the number of particles at the bottom of the Gizmo. And I've added some neutrons, and I can see that they've gone into the center as well. I've added some electrons, and they are in the outside part of the atom. So let's take a moment, use this information to answer these questions. A, which particles are located in the nucleus? The nucleus is the center of the atom. B, which particles orbit around the nucleus? Type your answer in here. C, turn on Show Element Name. That's in red, so let's go up here and click Show Element Name. The element I have created with 4 protons, 4 neutrons, and 6 electrons here is called beryllium. Actually, this is an ion, so I'm going to make it the same number of electrons and protons. What causes the element name to change? Well, let's take a look. When I changed the electrons just now, that did not change the name beryllium. If I change the neutrons, that changes some things, but it doesn't change the name. Let's see what happens when I add or subtract protons. Okay, so adding or subtracting protons causes the name to change. So write down your answer to what causes the element name to change here. All right, let's move on to activity A. And for this one, it says to use the arrows to create an atom with 2 protons, 2 neutrons, and 2 electrons. Okay, I can see what's making up the atom down here. And so I will add 1 more proton, so I have 2. We'll add 2 neutrons, and I'll add 2 electrons. It says turn on show element name, which I have checked. And if we look at observe for question number 1, it also says to turn on show element symbol and show element notation, which I have done right here. Now you can see a notation that has the element symbol and some numbers, and it looks just like the labeled symbol or the labeled element notation that you see over on the worksheet. The worksheet tells you what each of these parts is called. The 3 numbers surrounding the element symbol are the mass number, so here's the mass number in the upper left-hand corner, the electrical charge, which is in the upper right-hand corner. You won't see a number if the atom is neutral, if it's a neutral atom. You will only see a number when the number of electrons and protons are not the same. And finally, the atomic number. The atomic number is on the lower left-hand corner of your element notation. Now let's do an investigation. Watch how the numbers change as we add or remove particles. The first part says which number, and when we say which number, we're referring to atomic number, mass number, or electrical charge number. Which number is equal to the number of protons in the atom? So let's see if we can figure this out. Right now this atom has 2 protons, 2 neutrons, and 2 electrons. We can rule out the mass number because the mass number doesn't equal 2. This number doesn't equal 2 either. Down here, the atomic number, that says 2, but it could be any of these right now. So let's see, does this change if we change electrons? No, it doesn't. Does this number down here change if we add neutrons? No, it doesn't. Does the atomic number change if we add protons? Yes, it does. So if I have 3 protons, now I see a 3 in the lower left where the atomic number is. Go back to your worksheet and answer 2A. 2B. How can you calculate the number of neutrons in an atom? Well, let's take a look. Right here we have a total of 4 for the mass number, and we have 2 protons. We know by looking down here that we have 2 neutrons, right? So how can we use these numbers to come up with our 2 neutrons? Let's take a look at another element. Let's play around with this a little bit. If I add some particles here, now I see that I have 4 neutrons in this atom of lithium, and I have 3 protons. How can I calculate the fact that I have 4 neutrons from these 2 numbers? What can I do with these 2 numbers to get the answer 4? When you figured it out, type the solution into the box on 2A. All right, and for 2C, which particle, proton, neutron, or electron, has a positive charge, negative charge, and no charge at all? Well, a part of this simulation that will help us figure that out is to look at the charge number on the element notation. So if I take my electrons and I start adding electrons. What happens to the charge? All right, we were at nothing. I added an electron, it became negative. As I add more electrons, it's getting more negative, right? So we can infer that electrons have to be what type of charge? All right, let's go up to the next one. If I add more neutrons, it doesn't change the charge at all. So would you say neutrons are charged or not charged? If I add protons, okay, what happens to the charge of beryllium as I add protons? It becomes more and more positive. So what type of charge does a proton have to have? And I take them away, it becomes less positive. Type your answers into the boxes on 2C. All right, let's take a look at number 3. Number 3 says analyze, so we're going to do some thinking. An isotope is an alternative form of an element. Each isotope of an element has the same number of protons, but a different number of neutrons. The isotope is represented by the atomic symbol and mass number, such as He4. Okay, so if we look at the element notation, you're going to use the atomic symbol, and then you're going to put the mass number that you see in the upper left-hand corner after the atomic symbol to label a specific isotope of an element. Some isotopes are stable. That means that they won't fall apart in nature, they won't turn into other elements. While others are radioactive, which means the atoms decay over time and emit radiation. So what are the stable isotopes of carbon? Well, first we have to get to the element carbon to find that information. And I know now that if I change the number of protons, I change what element I have. Okay, so right now I only have 3 protons. Starting at the beginning, 1 proton is helium, so let's just keep adding protons until we get to carbon. Oh, there's carbon. So 6 protons gives you an atom of carbon. I'm going to make this a neutral atom by making sure I have the same number of electrons. All right, now we want to find out which isotopes of carbon are stable. Well, if I leave it with a total mass number of 10, that means 4 neutrons. It's radioactive, so you can see that in the upper corner here. So carbon 10 is not stable. Let's add another neutron. Adding more neutrons increases the mass number, but carbon 11 is also radioactive. Let's add another neutron. Carbon 12 appears to be stable. In fact, carbon 12 makes up 98.89% of all carbon atoms on Earth. All right, let's see if we can find any more. Oh, it looks like carbon 13, C-13, is also a stable isotope and makes up 1.11% of carbon elements or atoms. But if I go one more, if I go up to carbon 14, then it becomes radioactive again. All right, so let's go back. It was carbon 12 and carbon 13. All right, so let's go over to our worksheet, and this is how you will type in your answers. So there's carbon 13. What was the other stable isotope? All right, type in the second stable isotope here. All right, let's do the same thing again with nitrogen. All right, so let's take a look at nitrogen now. So it says, what are the stable isotopes of nitrogen? Well, if we add a proton, we get to nitrogen. And it says that nitrogen 15 is also stable. Let's see what happens when we take away a neutron. Well, now we get to nitrogen 14. Nitrogen 14 is also stable. All right, so those are two stable isotopes. Let's see if there's more. Nitrogen 13 is radioactive, so let's try the other way. Let's see if we can build a larger stable isotope. Oh, and nitrogen 16 is also radioactive, so it looks like we have two stable isotopes of nitrogen, and you can type your answers in 3B. For 3C, we're looking for radioactive isotopes of oxygen. Oxygen has 8 protons. And here we have oxygen 17. Oxygen 17 is a stable isotope. If we take away a neutron, now we have oxygen 16, and it says that one is also stable. So let's take another neutron away. Oxygen 15 is radioactive, so that is a radioactive isotope that we can list in 3C. If we take another neutron away, it will be radioactive as well. So oxygen 14 is also radioactive. All right, so if you get too few neutrons or too many neutrons, then you tend to create a radioactive isotope. So we'll go back to our stable isotopes. We had 16 and oxygen 17, and oxygen 18 is also stable. But if I add too many neutrons, I get to oxygen 19, and now the really large isotopes of oxygen are also radioactive. So there we've talked about 3 isotopes of oxygen. You just have to choose 2 and type in the element symbol and the atomic mass number for those isotopes here. All right, let's look at number 4, the practice. This is kind of a mixture of everything we've done so far. I'll reset this. 4A says, how many electrons are in a neutral atom of lithium? Well, let's make an atom of lithium by adding some protons. Let's make it neutral by adding electrons, and then we can count how many electrons are in the electron cloud. So we know it's neutral when this charge number disappears. Okay, so now you can type your answer in to 4A. 4B says, how many neutrons are in an atom of magnesium 25? Well, I see that isotope notation that we were just using that tells me I need to add protons until I get to magnesium, and then I need to add neutrons until I get to a mass number of 25. All right, I want to make it neutral so that it's an atom and not an ion. And now I'm going to add neutrons until I get to a mass number of 25. Okay, you can use the numbers below here to answer how many neutrons does an atom of magnesium 25 have. 4C, what is the mass number of an atom that has 5 protons and 5 neutrons? Let's take a look. Let's add 5 protons. Okay, so we have 5 protons. There's the atomic number. I'm also going to make it neutral. I don't want an ion. So now I have 5 protons and 5 electrons. All right. It also says 7 neutrons. Okay, so now I have 5 protons and 7 neutrons, and I can see the mass number up here. All right, but where did that mass number come from? If we take 5 plus 7, what do we get? Put your answer here for 4C. 4D. When an atom is charged, it is called an ion. How many electrons are in oxygen 2-? So we call this an oxygen ion. Well, let's go to oxygen. There it is. And now it says 3+. We want it to say 2-. So if I take away electrons, it just gets more positive, right? We need to add positive particles to it to make it negative. Did I say add positive? You need to add negative particles to it to make it negative. There we go. So we're adding negative electrons. And now we have -1. Now we have -2. Okay, so you can see we have a total of 10 electrons, right? And that's what's going to go in our answer box. I also want to point out that we have 8 protons and 10 electrons. We have 2 more electrons than we have protons, and that's what explains that 2- number up there. All right, let's take a look at 4E. It says how many electrons are in magnesium 2-? So let's add a proton and make it magnesium. Oh, add several protons. And it looks like magnesium is already at a 2+. Right? So now we take a look. It's still at 10 electrons. So the magnesium 2+ ion has a total of 10 electrons. All right, also notice that this positive ion happens when we have more protons than electrons. All right, we're moving on to activity B. This is the last section of the assignment. And we're going to follow the red instructions, create a neutral hydrogen atom, which we have done right here with 1 proton and now 1 electron. And the question is, how are electrons arranged around the nucleus of an atom? So it tells us to add the electrons to the atom until we've used them all. All right, so how are these electrons arranged? Are they random, or is there some order to it? Right? We don't really need to pay too much attention to how they're moving, but how they're arranged. Type your observations in where it says number 1. All right, number 2 says analyze. We're going to take a look at how exactly the electrons fit in here. All right, so it says electrons are arranged in orbits called energy levels. The gizmo shows all of the first 2 energy levels, but only part of the 3rd energy level. 2A says how many electrons can fit in the first energy level. So let's take a look as we add them. Oh, now we're to the 2nd level, so let's go back. So how many electrons went into the first energy level? Type your answer in. 2B, how many electrons can fit in the 2nd energy level? Oh, too far, too many. All right, so how many went into that 2nd energy level? You can pause and count. And then lastly, how many electrons fit in the part of the 3rd energy level shown? All right, you can type your answer in here. All right, that's it for this assignment. Once you've completed all of your answers, you can go back to Canvas and submit this a document, turn it in, and you will be done.